from our textbook basically is to apply appropriate mathematical tools to solve for the vibrations, response of vibrations to non-periodic force. Non-periodic force function basically is a very general force, you name it. As long as you can provide a description for the force, you should be able to solve for this one. So here we're shooting for is very general and very powerful the approach to this one. Okay, so the method to solve for these problems, we've been gone through the first one, including the plot transform, and we've been exercised quite a bit. And later on, I will further demonstrate with more examples. The second approach, and that is we call the impulse response method. So basically, impulse response method is related to sorry, here I have the wrong spelling. Convolutional, C-O-N-V-O-L-U-T-I-O-N-A-L. Okay, so that is the spelling. The two methods are related. Basically, these two sections simply combined with together simply is to tell us we're going to use the convolutional integral approach, and that is a time domain integral compared to the plot transform that is in the S domain. So the two methods sometimes they supplement to each other. Depends on the situation, depends on the number of the systems. Sometimes one approach is faster, easier, the other one vice versa. Okay. Sorry here, kind of wrong spelling, kind of share myself, put onto YouTube. So I hope using the last 3 lecture hours by Friday, we can try to demonstrate with the examples with some kind of the mixing the two methods. Okay. Here I have prepared quite a few slides, and I updated a little bit. So I will let you know kind of new pages I added. Basically, before we go over the details, maybe I don't have time to go over the details, but here I try to accommodate with the concept here, then we quickly go over the content of the slides. So listen to this carefully. The idea of applying the convolutional integral for solving the function is this. If we consider a general system, mx double dot plus cx dot plus kx, and equal to ft, and ft can be arbitrary, this one can be an arbitrary functions. Okay, doesn't have to be periodic, doesn't have to be harmonic, can be arbitrary. So here we're talking about is to, in mathematics, is I'm going to review or introduce you a very powerful mathematical tool, okay? For this case, and for example here, we describe these functions by this. For example, follow up my plotting here. So if this is a ft, okay, the solution process in terms of concept is this. We conceptually, we decompose this function as a combination of such small string. Okay, So we try to decompose in the time domain these functions as the combinations of such small strip. So that means let me write into this. So here, let me highlight the profile of these functions. Okay, and this one is the first small strip here. Then this one is the second one. Okay, so for each small strip, it just happened at very small time period. And let me call it delta t. And this one is happened at from, for example, this is called a tau, and the period is delta t. Okay, and for example, let me say this one is limit. Yeah, just arbitrary time. Tau. Let me pick up the information there. Tau, and this is data. Let me follow this one. T, just delta t. Okay. So this is a combination of the many small strips, and so that is a function decomposition. And for each one, if we are able to find the response of the system to such a small strip, then we simply decompose the things together. So that means here is the system response. So let me use palette. Okay, so the system response to this one is corresponding to this. This is x of t. Okay, so right now the system response to this particular strip, and say, let me do something. This is the damped systems. And this is a small strip. For example, if the system response is something like this one, let me draw it carefully. Okay, so basically this is a damped system under certain small kind of strip force. And in concept, let me schematically draw the system response like this. Okay, so for this one, again, we have the similar way. The system right now for this case is start to respond at time 0 when we have the strip is inactive. Okay. For the second one, the second strip didn't start it until when time equal to tau. So let me put this one carefully. So this one tau corresponding to is here. So this is the moment tau when the system is going to respond. So the system won't respond until that moment. So that means here, let me highlight. So that means system was started from here. Okay, so furthermore, let me do the general descriptions if the strip is here. If we have the strip is here. Okay, so this is the moment tau, and this is the delta t. Okay, so then the system won't respond until tau. Okay, so that means the system will simply shift its response to that moment later. So for each of the response, the shape of the systems, for each response here, the shape of the system's function, the system response is the same. they simply delayed by the moment when corresponding to the location of the strip in the time domain. Be good? Okay. So the total system response to such a continuous function, from here you can see if we are able to decompose this force function into the many small the strips in combination in the time domain, then the system response simply is such a response we simply add it up together in the time domain. Be good? So this is a big concept and what we're going to learn here. And so by looking at this one and be more careful, the plotting will be like this one here. So this is a concept. Basically here we're looking for the response of the system to the very general functions simply in concept as long as we are able to theoretically to formulate what is the function type for each of these one. Then we simply add them together, then that is our solutions. That's it. Okay, so the remaining of our the learning in the contents here is to first one, to find out what is the mathematical description of such a response. The second one is how do we add up those functions together? Okay, simply 2 steps. Okay. So the first one I want to show you is how to describe the response here, so that we can have the new sections. Okay.